Hello, my dear students. Mr. Sakite Patrick welcomes you all to today's lesson. Our lesson for today is on sets. So we'll be looking at sets and operations on sets. Now, let's look at our lesson objectives. By the end of the lesson, the student will be able to identify the various types of sets. That's the first objective. And the second one is perform the basic operations on sets. So by the end of this lesson, you, my students, must be able to identify the various types of sets and perform the basic operations on sets. Now, what is a set? A set is a well-defined collection of objects. The collection of the objects of a set is based on a well-defined properties and characteristics. Now, as I said earlier on, a set is a collection of well-defined, distinct objects. So the objects are collected based on what? Specific what? Properties or characteristics that exist between them. Now, the objects of a set are called elements or what? Members of the set. And sets are denoted by capital letters. And in sets, we use what? Curly brackets. So if you see this one, there's a curly bracket here, there's another what? Curly bracket here. Now, describing a set. How do we describe a set? A set can be described by A. Listing the members of the set. Listing the members of the set. For example, the set of even numbers from 2 to 8. So listing this, the members of this set, we have set A equal to 2, 4, 6, 8. So the numbers are ranging from what? 2 to what? 8. So there's the beginning from the start. The first number is what? 2, and the last number or the member of the set is what? 8. Now the second way of describing a set, we have stating the property. For example, B is equal to even numbers less than 10. So the set A and the set B are talking of the same thing, but with the set A, they have listed the members of the set, and then with the set B, they have stated what the property of that set. Now let's come to the C, the third way, using the set builder notation. For example, the set C is equal to X is such that 2 is less or equal to X, less or equal to 10. Examples of sets. Set A is equal to Monday, Tuesday, Wednesday, then what? To Sunday. So these are the set of what? Days of the week. Once you see this dot here, that means what? That means that there are some what? Members of the set that has not been what? Listed here. There are some members of the set that has not been what? Listed here. So if you continue, we get what? Thursday, Friday, then what? Saturday here. Now the second one. Set B is equal to what? 1, 2, 3, 4, 5. So these were the set of what? Natural numbers from 1 to 10. The set of natural numbers from 1 to 10. Now let's continue the set C. This is what? The set of what? Natural numbers. Now with this one, the B and the C, let's come to the C. With these 3 dots here, that means what? The last member or element of the set cannot be what? Found. So with this one, if you see, the set what? Is what? Not ending. It's infinite. So the set B is what? The set of what? Natural numbers from 1 to 10. And the set B is what? The whole what? The set of what? Natural numbers. The set of what? Natural numbers. So from 1 to what? Infinity. That's a set D. It's what? The set of what? Names of people. So we have Kofi, Ama, Yao, and Kwesi. So these are the set of what? Names of what? People. Now types of set. We have now or empty set. It is a set with no element or member. The number of elements in a now set is 0. So there's no element or member in that set. For example, set P is equal to this or this symbol. Please, the empty set. With empty set, we put what the curly bracket with no number or no element in it. So the moment you put 0 here, 0 becomes what? The element of this set. So we put what? No number here, or there's what? Nothing here within the curly bracket. Now let's continue with what? The unit set. It is a set that has only one element or member. For example, A is equal to, set A is equal to 2. Set B is equal to Kofi. So Kofi is the only element of this set, and this one, the set A2, there's what? 2. The number 2 is the only element of this set. Now let's continue with types of set. Finite set. It is a set that takes all its elements. A finite set is a set which can list all its elements. For example, set Z is equal to this what? The set of even numbers from 1 to what? 10. So the last element of this set is what? 10. So it's finite. The set Y is what? Prime numbers from 2 to 13. Prime numbers from 2 to 13. So with this one too, the last element of this set is what? 13. The last element of this set is what? 13. Now, let's continue with what? Infinite set. It is a set that cannot take all its members or elements. That is, an infinite set does not come to an end. So with the infinite set, we cannot determine the last member of that set. With the infinite set, the last member of the set or the last element of the set cannot be what? Determined or found. Now, types of sets. Let's look at this one. The first one, the set of days of the week. Since within this set, the Sunday is the last member, we know that this set is what? Finite. B, the set of what? Natural numbers from 1 to 10. So we can find the last member of this set. So this set is also what? Finite. Now, the C, the set of what? Natural numbers. With this 3 dot, that means the set is what? From 1 to what? Infinity. So the last member of the set cannot be what? Identified. So this set is what? Infinite. Now, the set of names of people. Since Kwesi is the last member of the set, this set is also what? Finite. So that's it. Now, relationship between sets. 2 or more sets can be related as subsets, equal sets, or equivalent sets. Subsets, equal sets, or equivalent sets. Now let's look at the first one, subsets. Subsets. A set M is said to be the subset of another set N if and only if all the elements of M can be found in the set N. So a set is a subset of another set if all the elements of that set can be found in the given set. Now let's continue. Equal sets. 2 or more sets are said to be equal if they have identical or the same elements. For example, if set A has the element 1, 2, 3, and the set B has the element 1, 2, 3, that means set A is equal to B because A and B have the same what? Elements.